just a couple of reminders for this week. Tomorrow is a mastery check. Okay. Friday is digital learning. Okay. And what you're going to do on Friday is you're going to do this review guide. So you're going to complete it. Now we're going to do a couple of pieces in class, but majority of it's going to be done on Friday. I'll have a video that walks you through it. It'll only take you about 15 minutes. Remember, test is Monday. So when you come in on Monday, I'm only going to review for about 10, 15 minutes, and I'm going to give you the test. Okay, so you got to make sure that you're coming in ready to go. Okay, we're going to do 1 through 3. So it says determine the 10th term of the sequence. Is this geometric or arithmetic, and how do we know?
What is it called?
Where's it going up by?
It's going up. It's going times 5.
Multiplying times -5. Okay. So it's not arithmetic. We got geometric. Okay. Now, in order to determine the 10th term, we're going to use the explicit formula, which is this. So what is a sub 1? What's our initial amount?
5.
And our rate was -5. And we want to find the 10th term. So we're going to plug in 10 in for in. Can we plug this into our calculator and tell me what you get?
5 times -5.
5 times -5 raised to the 10 minus 1. Okay, so this is going to equal -9765625. Write the explicit formula for this. Is this arithmetic or geometric? So it's arithmetic. What is it going up by?
4.
Okay, so we're up and by 4. So the explicit form for arithmetic is going to be a sub n equals a sub 1 plus d times n minus 1. Okay, so what is our first term? What was our first term? A20. Okay, and our common difference was? And then we have n minus 1. Now, many times it's going to ask you to like simplify this. So we can distribute, and that's going to give me -20 plus 4n minus 4. And if we simplify that, that's going to give us -24 plus 4n. On the next one, is it arithmetic or geometric?
It's arithmetic. Oh, geometric.
Why is it geometric?
Because it's kind of like down my consistent number.
So going down, what if we took 500? I'm sorry, what if we took 350 and divided it by 500? Well, that would give us 0.7. What if we took 245 and divided it by 350? That gives us 0.7. So really, we're multiplying by 0.7 each time. So this is going to be geometric. Since it's geometric, what we're going to do is write the explicit formula. Over there on the board, you can see that the explicit formula is this. So what's our first term? 500. What's our rate? 0.7. And then we're going to raise it to the n minus 1. You always want to make sure that you write this as equal to a sub n, just because that's the correct way to write a formula. It has to equal something. It says, after what year will it fall below $20? So if we took our equation and we set it equal to $20, when would this happen? How can we figure that one out? Well, there's a couple different ways we could have done this. We could go into Desmos. Okay, and we can type it in. But just remember that you need to put the x minus 1, not n minus 1. And you can set it equal to 20. So when we zoom out, we could look at after 10 years, it'll be below. Okay. So after 10 years, or if you want to be technical, 10.025, okay, it will fall below. Okay, so on here, which one is quadratic? Blue. Why is it blue? Okay, it's a parabola. It looks like a U, right? Okay. On the next slide, which one is exponential? Green. Why is it the green one? Okay, it's either decaying or growing when we're dealing with exponential, and this one has a horizontal asymptote too. Okay, which one is linear? Red, because it's a straight line, right? What about the next one? What must be true about the y values in order to be linear? To add, what do you mean? It has to be consistently going up, right? And in order for it to be linear, remember our y-intercept is this number that's chilling out here, right? So if our y-intercept is 3, guess what? It's plus 3 at the end. Okay. What must be true about the y values in order for the quadratic, or in order for it to be quadratic? Is it first difference? Is it second difference? Or is it multiplication? So like on here, if I find the first difference, I see this is 1, and I see this is 1, and then I see this is 3, and I see this is 3, no, 5, sorry, 5. Okay, so, and this is minus 1. And the difference on this one is 2, and our second difference is the same. So since our second difference is the same, that's going to be quadratic. What about this one for exponential? What has to be true about their y values? That they'd be going up by some type of multiplication, right? Exponential has multiplication. And you said it was multiplying by 2. It's not always going to be 2. It could be like another number. But in order for us to find that, we're going to take the second term and divide it by the first term. So 2.5 divided by 1.25, that gave us 2. Okay. Number 7, select all the linear functions. Go ahead and take a moment. Go to slide 7, pick the linear function. We got one person who answered. Go to slide 7. Okay, y equals mx plus b, right? Okay, so question for you. Is this last one linear? Okay, why? Why not? There's no x. Well, okay, at the bottom it says y minus 4 equals x. So here's my x. So is this linear? Why? Because what? You can move the 4 over. If we move the 4 over, what do we get? X plus 4. Now is that in that y equals mx plus b form? Yes. Okay, so just because it's written a little funky doesn't necessarily make it not linear. Okay? We okay on that? All right, looking at slide number 8. Let's go ahead and answer slide number 8. Do you agree or disagree on this one? Look at the board. Do you agree or disagree on this one? Thanks, babe. Agree? Okay, why? What makes this quadratic? X squared. So we're looking for things that have that x squared, right? Okay, does the second one have x squared? No. What about the next one? We have 4 times 2 raised to the x. Is that an x squared? Does it have this in it? No. So what is this one called? Exponential. Okay, what about this next one? So this is not quadratic. What about this next one? Y equals 3x minus 5. Is that quadratic? No. What about the next one? Yes. Okay. You should be able to pick up on that linear and quadratic pretty quickly. Go ahead and go to slide 9. Go ahead and answer. Pick the ones that are exponential. Exponential. So when we say exponential, that means that there's going to be an x in the exponent. take a second. Equations belong to each type of function. Okay, so like if you were telling your friend like, hey, this is how you pick a quadratic, this is how you pick a linear, this is how you pick an exponential, type me like a 2-sentence thing. Okay, so I should hear a lot of typing. Get off your phone, wake up, let's go, lock in. Thanks. What would you tell your friend and how to determine if it's a linear, quadratic, or an exponential? Go ahead.
Quadratic has a U.
Okay.
Exponential is like it's fading or like gaining a fade. Linear, it's a straight line when it comes to.
Okay, and linear is a straight line. Okay, so he's talking about the graphs. What about the equations though? Like, how do we determine from an equation? Yes. I know you have the answer. I can see it. What you got? Okay. So it's just got an x, right? What about quadratic? X squared. And then what about exponential? Okay, so it's got x in the exponent. Okay. How about a table? How do we identify that? Like if we have like this little table, we have x, y, we got a bunch of numbers. How do we figure that out? Hey, Sebastian. Tap Felix. Wake up. How do we figure it out from the table, Sean?
It's like going up by random numbers or going down.
Okay, so when you say random numbers, what do you mean?
It's not the same.
It's not the same. Okay.
Like one could be -5 and the other one could be like 3.4.
So what we were seeing on one of those, we were seeing like 5, -25, 125, right? Yeah, that was our y values. So what are we going up by each time? Okay, so it's not random numbers, we're multiplying by 5, right? So exponential is going to be that multiplication. Everybody here, Sean? Okay, cool. What about quadratic? How do we figure that out from a table? Let's do the easy one. How do we figure out linear? It's adding. That's that first difference, right? Okay, quadratic is very similar, but we're going to look at the second difference, right? So we're going to subtract that one more time. Okay. All right, go ahead and back out of that, Desmos, and go ahead and go to the one that says comparing linear, exponential, and quadratic. So, no, go ahead and skip it. Okay. Go ahead and go to the other one. And I want you to go ahead and sort these cards. I want you to sort them into linear, exponential, and quadratic. I'm going to give you about 3. So a lot of y'all were putting, a lot of y'all were putting these together. Let's have that conversation. This does have a horizontal asymptote, but this guy down here is going to be actually a different type of function that you're going to learn about a little later. So this guy's not exponential. Did everybody see it? Need you to look because I saw a lot of mistakes on this one. Okay, exponential is going to go off and it's not going to go past that point. Okay. For quadratic, a lot of you put the little U-shaped ones together. It was really good. Okay. Some of y'all put this V-shaped one with the linear. What is that one called? Okay, so is that technically linear? Nope. Okay, a lot of y'all put this one right here with the quadratic. Is that a U shape? No. Okay, so that guy shouldn't have gone with him. Okay. These were all exponential. Okay. This one right here, x technically is not linear, it's a constant. But if you put it in here, it's okay for right now. We're gonna go ahead and look at slide 2. How'd you know if it was linear, exponential, or quadratic? Somebody summarize it for me. Say again.
My answer.
Look at your answer. Bum, bum, bum. Sean said linear, straight line, constant. Exponential is fading or additive fade. And quadratic has a U as a graph. Good. Okay. Go ahead and go to slide 3. I want you to go ahead and match up those equations. You should have no problem with identifying these after today. Slide 3, let's go. Slide 3. So look at your screen. Look at your screen. Okay, see if you're right or wrong. Here are all the correct answers. Okay. All right, hey, let's go. Are you ready? Okay. So, are you ready? Okay. So on this one, we got quadratic, then we have linear, and then we have that exponential. Okay. Let's go ahead and skip to slide 7. Let's go ahead and skip to slide 7. Go ahead and sort slide 7. Go ahead and go to slide 7. Go ahead and sort slide 7. Walk through it. So linear is going to be that straight line. Quadratic is going to be that U. And exponential is going to have that X as the exponent. Okay. Quadratic, again, it's still going to have that squared. Anytime that we see that. Linear is just going to have an X. Okay. Now we want to look at the tables. So which one has a consistent number being added each time? Good. This table is going to have adding 9 each time. Okay. Are we multiplying by anything in these two tables? Well, from -4 to -1, what happened?
It's being multiplied. No, it's being. Wait, what?
This is not being multiplied, right? This one's being added.
It should be quadratic.
It's going to be quadratic because that second difference is going to be the same. And this one's going to be exponential because if you take 20.9 and divide it by 22, it'll give you the same thing as 19.85 divided by 20.9. Okay. Okay. So average rate of change. This is like a fancy way of just saying slope. Here's my formula. Okay. You have to know the formula. I'm not going to give it to you. You have to know the formula. I'm not going to give it to you. Okay. Tomorrow is your mastery check. There are 3 questions. One is going to ask about the y-intercept. One is going to ask about average rate of change. And one is going to ask about in behavior. Okay. You're going to be comparing 3 different functions using these 3 key features. Okay. So let's go ahead and talk through which one has the highest y-intercept. Okay. Now you might be given a table, you might be given an equation, or you might be given a graph. Okay. So it just depends. But looking at our table here, our y-intercept is when x is 0, what's our y value? Which one of these, the exponential, quadratic, or linear, has the highest y-intercept? Exponential has the highest y-intercept. Okay. Average rate of change. We're going to find this over the interval from 0 to 1. Okay. They have to give you an interval. Okay, so they have to give you an interval in order for you to do this. So 0 to 1 is going to be x1 to x2.
Can it be infinity because it's going up?
No, this is average rate of change. So from 0 to 1, we're going to find the slope. Okay, so on here for the quadratic, we have x1 is 0, x2 is 1, y1 is -4, y2 is -1. I'm going to take that and plug it into my formula. So I'm going to have -1 minus -4, which will make that plus, 1 minus 0 on the bottom. When I simplify this is going to give me 3/1, which equals 3. I'm going to compare that with the other functions. So for instance, right here, if we go from 0 to 1, we're going to set this up the same way. So this will give me 24 minus 15 over 1 minus 0. So that'll give me 9. Which one has a higher rate of change? The one that has the largest rate of change is going to be the linear function on this one. Okay? You have to show your work on this. In behavior, which function has an in behavior where it has, as x is approaching positive infinity, y is approaching positive infinity, and then as x is approaching negative infinity, y is approaching negative infinity. So as we go to the right, it's going up. As we go to the left, it's going down. Which one does that? The linear function, right? Okay.